Oh, hi! In this video, I will show you how to build a custom PC on a budget and then install a Linux distro as an operating system. For this build, I decided to go with Nobara Linux. Nobara is a Linux distribution that comes pre-configured for gaming and content creation, meaning that it includes GPU drivers, Steam, and plenty of other useful tools right outside of the box. It's beginner-friendly compared to other distros while still giving you the flexibility of a full Linux system. Disclaimer. While this video was originally meant to be a full tutorial, some parts of the build weren't recorded clearly enough to actually serve as one, so please use this video alongside other guides. If this is your first PC ever, I seriously do not recommend using Linux as a daily driver just yet. It can be confusing and extremely frustrating at times. Windows is a much safer bet. With that being said, on to the video. Before we start the build, here's a super quick explanation of the main PC parts, just in case you're new to this. The CPU, or processor, is the brains of the computer. It does the main calculations. The motherboard is the big board that everything plugs into. The RAM is the short-term memory. It keeps everything the PC needs right now. The GPU, or graphics card, handles games and graphics. The storage, or SSD, is where your files and system are stored. The PSU is the power supply. It sends electricity to everything. And then the case is what keeps all the parts protected and cooled. Please do note that this is a gross oversimplification of how PC components actually work. The way they actually function is really quite fascinating, and if you have the time, I encourage you to do your own research. For my build, I went with a Ryzen 5 3600 as my CPU. It's a really solid budget CPU with 6 cores and 12 threads. That's plenty for gaming and normal everyday tasks, and it's also quite cheap on the used market, which is perfect for a budget build like this one. My GPU is a RTX 2070 Super. It's not the newest thing in the world, but the used price to performance is great and it can handle 1080p gaming very well. I have 16 gigabytes of CL16 DDR4 RAM clocked at 3200 megahertz. That's basically the standard good amount of RAM for budget builds, and the speeds are also good. For storage, I'm using a 1 terabyte SSD. It's an M.2 NVMe, so it's fast, reliable, and it'll also give me enough space for Nobara, apps, and running a few games without worrying about running out of room too quickly. My motherboard is an Asus TUF Gaming A520M Plus Wi-Fi. It's a newer chipset than B450, and it supports my CPU while still having all the ports and features that I need without spending any extra money. For the power supply, I went with a 550 watt unit. It's just about enough for a Ryzen 3600 and a 2070 Super, even under load. And then finally, the case. It's nothing crazy, just a simple budget case with a couple of fans included. It has good airflow, decent cable management, and honestly, it gets the job done. Now it's time to actually build the thing. The first step is to place the motherboard on the box it came in. You should see some extra accessories inside of the box, like an I/O shield, Wi-Fi antennas, or SATA cables, but you don't need those right now. Lift the socket lever up and slot the CPU in by lining it up with the triangle in the corner of both the CPU and the socket. Gently set it in, applying no extra pressure. Once it's in, you can gently wiggle it to make sure it's secure before lowering the lever back down. Next is the RAM. Unclip the second and fourth slots to take advantage of dual-channel memory. Line up the RAM with the notch before applying even pressure along the RAM stick. This will take more force than you expect. When it's in, you'll hear a clicking noise. Do the same for the other RAM stick in the other slot. After that, slide the SSD into the M.2 slot with a standoff in the correct spot so that when it screws down, it lays flat. When that's done, it's time for the CPU cooler. Every cooler is different. The one I'm using is just a stock cooler that I had laying around, but most of them will have you remove the brackets that come with the motherboard before screwing the cooler directly into the back plate. This marks the end of the motherboard prep phase. Now it's time to actually install it into the case. First, make sure that all the standoffs are installed in the correct positions. These are those little metal risers inside the case that the motherboard screws into. After that, snap the I/O shield into the place shown in the video. I don't have one because I bought my motherboard secondhand, but unless you did the same as me, you'll be fine and you'll see it in your motherboard box. Once the standoffs are in place, line up your motherboard with them and gently lower it into the case, making sure not to scratch the backside of the motherboard or to damage the ports near the I/O shield. Now, my footage inside the case turned out way too dark to properly show what's happening. But if you want a really clear, easy to follow guide on how to position the motherboard, tighten everything down, and honestly do everything else, I highly recommend the Linus Tech Tips POV PC build video. It shows the whole process from the builder's perspective and makes everything super easy to understand. Alright, so assuming that at this point you have a working PC in front of you, the next step is to load into the BIOS and enable the RAM's DOCP profile, or direct overclocking profile. This will set the RAM to its rated speed, the speed advertised by the seller. Do note that this can sometimes introduce a little instability, but it's usually fine. Next, on a separate computer, I prepared a USB drive with Ventoy and copied the Nobara ISO onto it. Ventoy is a formatting tool that sets up your USB so that you can drop ISO files onto it and then boot them directly. One thing to note, using a slow USB can make this process take an extremely long amount of time. In my case, it took 1 to 2 hours before I realized Nobara wouldn't even boot properly. I ended up switching to a faster USB later, which inevitably worked, but if you're following along, I really recommend using a high-speed USB drive. It'll save you a lot of time and frustration. With the USB formatted and my Nobara ISO installed onto it, I took it out of my laptop and plugged it into the PC. When I rebooted it, I was met with a boot menu similar to this one. After selecting my ISO, I was greeted with this other boot menu. Upon selecting the Start Nobara 42 option, the PC booted into the installer for Nobara. Once in the installer, click the Installer app in the top left to start the process. Just a quick note, everything you're seeing here was recorded on my main PC using a virtual machine, just so that I could show you the installation process clearly. But don't worry, the steps you will go through are exactly the same as the ones you see here. I started the installer and selected my language on the first screen. Then I chose my location. After that, I set up my keyboard layout. Nobara usually detects it correctly, but you can adjust it here if needed. After that, the installer asks for your username and password. Nobara uses this to create your main account and gives you the option for automatic login. Next is the partitions. This is where you pick the location for Nobara to be installed on. For beginners, the best option is to erase the disk with no swap and the BTRFS format. If you want more information on SSD formatting, I will provide a link to a more in-depth guide in the description. After filling everything out, check if everything is to your liking in the summary page. After that, click Begin Installation and Nobara will start copying the files to your drive. Once you start the installation process, it should take around 10 to 20 minutes on an SSD. After it finishes, just reboot, remove the USB, and you'll boot straight into Nobara for the first time. After rebooting into Nobara for the first time, you'll see this welcome screen. This walks you through the basic setup, and it's a good idea to go through everything at least once. The first thing I did was check for updates. After that, I opened the Driver Manager. It's a really helpful tool that automatically installs all your GPU and other hardware drivers. If you're on NVIDIA, the Driver Manager will even install the proprietary drivers for you with one click. This is one of the reasons why I chose Nobara. It handles all this stuff without any extra terminal commands. Once I was done with that, I went through the recommended editions section. Nobara provides quick install for tools like Steam, OBS, Wine, and a lot of other gaming related packages. If you're planning to play games or record content, this makes the setup really straightforward. Once I finished all of the welcome screen steps, the system was more or less fully ready with all its drivers installed. At least, that's what it looked like. In reality, I was met with the weirdest buggy audio I've ever experienced. My headphones would default to their worst quality codec for no apparent reason. I would fix them, only for them to revert back to potato quality immediately after. After literal hours of troubleshooting, I finally managed to get them working. With the setup finished, I went ahead and installed a few games and ran a couple benchmarks to see how the system performs. One thing I forgot to mention is that only the installation process was recorded on a virtual machine. Everything from this point onward was recorded on the actual Nobara PC. First, I wanted to test those faulty audio drivers, so I booted up Ultrakill, a game with an intense soundtrack, to stress test them. And yes, I know the footage you're about to see is a little bit embarrassing, but do keep in mind that my mouse was not compatible with Linux, so I couldn't set up my DPI or my side buttons. Yet another reason why I do not recommend Linux for the average user. Also, here's a quick noise warning. Headphone users, lower your volume a little bit. This also doubled as a great test for the overall stability of the system, as Ultrakill is a very fast-paced movement shooter. The next benchmark I ran was the built-in Cyberpunk 2077 benchmark, just to get a clear idea of how this system performs in a demanding real-world game. For comparison, a Windows PC with the same exact hardware typically averages around 60 FPS in this test. On my system running Nobara at 1080p with high texture quality and ray tracing set to low, I got an average FPS of 58. So in terms of raw performance, Nobara came surprisingly close to Windows, just within a couple of frames. That is well within the normal variation for Cyberpunk's benchmark, and it shows that this setup is absolutely capable of running modern AAA games, even with some ray tracing enabled. Overall, the benchmarks were solid, and the system performed pretty much exactly how I expected it to. Cyberpunk especially showed that Linux, or at least Nobara, can get very close to Windows in real gaming performance. But with that being said, I want to be very clear. I do not recommend this setup for beginners, or for someone building their first ever PC. Linux can be amazing, but it also comes with a lot of weird quirks, bugs, and compatibility issues that you just wouldn't even expect to happen. If you're new to PCs, this can be extremely frustrating. I made this video to document my experience, not to tell anyone that this is the best way to build or set up a system. Please do your own research and don't use this video as your only source of information, especially if you're completely new to Linux. But if you're interested in experimenting, I hope this gives you a good idea of what to expect. Thanks for watching.